Okay, for B, a little bit tricky reading the question. What is the probability that a rejected roll has 2 faults? I started off thinking it had at least 2 faults because it didn't say exactly 2 faults, so I figured if it had 3 faults, surely it also has 2 faults. I was wrong. So the question should say has exactly 2 faults. I don't like the wording for me. So I worked out here the probability that x has 2 faults, and our lambda's here. But it says what's the probability that a rejected roll has 2 faults? So it's that probability divided by the probability of it being rejected, because it's kind of given that it's rejected. So you're only looking at the rejected ones. So we're looking at the probability of having 2 faults divided by the probability of it being rejected to get that, which is your answer in the back of the book. But as I say, the wording's a bit tricky because I was thinking a bit wrong there. Okay, so let's have a look at C. To cut down the number of rejected rolls, the manufacturer decides to halve the amount of wallpaper on a roll. Find the percentage of rolls that are now rejected. So one of the things of Poisson is that it's proportional. So if we had lambda for lambdas here, so we need to actually half that lambda because the rolls are half as big. So let's divide that by half. So execute clear 0.174353 divided by 2. That's our new lambda. Okay, so that's 0.0875 is my new lambda. Find the percentage of rolls that are now rejected. So we're looking for the probability of x being greater than or equal to 1, which equals 1 minus the probability of x equals 0, because even with 1 fault it's rejected. Any roll with a defect is rejected. Okay, so we go into stats, we go into distribution, we go into Poisson distribution, and it doesn't matter which one we choose, and we're looking at 0, and we're looking at 0.087175. So we've got that. Now we've got to go 1 minus that, so that equals 1 minus 0.9165. So let's go back to run. 1 minus 0.9165, and then its percentage says what percentage, so we've got to times by 100, so I'm getting there 8.35%. Yes, and that's correct, 8.35%.